So let's move ahead. Now we will talk about, so we have talked about the first question, what to measure using the data collection plan. We've also talked about how to measure. We talked about using sampling. Now we'll talk about the third question of measure phase, which is how to ensure what we measured is correct or not. Okay, and why this is important is because when it comes to Six Sigma project, there are sometimes measurement error takes place. Measurement error takes place means that, for example, if Simarpreet has measured something and Simarpreet gives this observation that out of 10, there are 9 correct and 1 defect. And if I do the same sample and I give it to Kishore, or I give it to Bhanu, or I give it to Mahesh, okay, they might come up with a different sort of measurement. Okay, so to ensure that there is no variation observed when different people are measuring the same equipment, that's why we take place the measurement system analysis into consideration to ensure that we don't have any measurement sort of error in place. So that's why MSA, which is called measurement system analysis, is one of the important technique that we do it in the measure phase to ensure that whatever is being considered, whatever is being measured is correct or not. So we want to measure it again so that we all are calibrated. Okay, so let's understand it. The formula for measurement system analysis is equal to observed value is equal to true value plus measurement error. Okay, so let's take an example, and I want you to answer this. If I go to a market and buy 1 kg of tomatoes, okay, and I come back and I have a weighing machine. I measured the same tomato again, and it came out as 950 grams. So the shopkeeper told me that this is 1000 gram, 1 kg, and I measured it, it came out as 950. So what is the true value here, and what is the observed value here? So is 1000 my true value, or is 1000 my observed value?
1000 will be observed value.
We don't know actually, because we don't know which one is. We don't know which one is accurate. Is the scale at the shop accurate, or is our machine accurate? We do not know that.
So let's assume that I am accurate. I am a standard. Okay. Let's assume that I am a standard.
Value will be ours.
1000 is the observed value. 950 is the true value.
Okay.
Yeah, and measurement error is 50 grams.
50. Yeah.
Absolutely. So observed value is the value that was being given to me, that is 1000 grams. True value is the actual value which comes out as 950 grams, and measurement error is the difference between the true value and the observed value. Okay, so in the measurement system analysis, when we look at any sort of data, we look at it in a suspective manner, and we assume that there might be some amount of variation there in place. Therefore, we measure the same data with a different operator or with a different standard, a standard who would never be wrong, and whatever the consensus comes out, we consider that as a perfect measurement system analysis. Okay, and why we do that is because there are 5 to 10 times there is a possibility, and I'll just talk about one of the situation here. We were doing a project on improving the efficiency of a particular process. Okay, and when we started the project, the target which was given to us is that the team is only 15% efficient, and they have taken a 2x target to improve it to 30%. So 15 to 30 they want to improve. Okay, so the project charter was signed off, everybody was aligned, we did the sampling, we did the data collection plan. When we reached the MSA, when there were 3 different people who looked at the data, we found that's not 15%, it is 25%. Which means there was a measurement error that was observed. There was a wrong way of calculating the efficiency at that point in time, which we never looked at. Okay, and therefore Therefore, we again, when we compare it with a standard, or when we do it with a standard, we came out as 25%. What do you think now? I'm asking you a logical question, and I haven't talked about it yet, but I want to hear from you. What do you think in that case you should do? Just any guesses, any logical answer? What do you think can be?
Yeah.
Haircut.
Please go
Sorry?
ahead. Go ahead.
Anybody can
Okay,
speak
so
up.
there are two type of. Should I go ahead?
Yeah, please.
Okay, so there are two types of error in this case. First one is by using, if a single person is measuring so many times, then there can be error due to that, and that depends upon that a person's style of measuring. Suppose using the same equipment, if there are three different persons are measuring, then again there can be one more error. So in this case, the first error is repeatability, and second is reproducibility.
Sorry to interrupt you, Piyush. I haven't reached there yet. I haven't reached there at repeatability or reproducibility, which I will talk about in detail. I'm just asking you a scenario. You have used all the permutation combination. You have taken 3 people into consideration, and those 3 people have done it again themselves also, and 3 different people have done it again also. Okay, there were a lot of trials happened. And later we concluded that it was not 15%, it was 25%. What would be our next point of action?
I think we should re-baseline.
Absolutely. We should re-baseline, wherein we should, first of all, we have taken into consideration that 15 is not correct, 25 is correct. Then we go back and re-baseline that 25% is currently we are at. So we should take a aspirational target, because 30% is very, very near to 25%. Okay. So to ensure that situation doesn't come, we would like to do a MS. So that's very, very important. So I just want to tell you that why it is important. Okay. So measurement, there is a variation which is due to the equipment. Okay. That technique is known as repeatability. We will discuss in detail that what is repeatability. Any variation which is due to the operator, that is called reproducibility. Okay, so these are the two terms which you need to remember. Any variation which is due to the equipment, okay, that is called repeatability. Any variation which is due to the operator, it's called reproducibility. So let's discuss what is repeatability and what is reproducibility. Repeatability is when we are measuring. So for example, Simarpreet has measured the tomatoes first time. Okay. Let's say there is a plant at my place. Okay. I haven't bought it from anywhere. There's a plant at my place, a tomato plant. I pulled some tomatoes and I measured it randomly, and the weight comes out to be 5 kgs. Okay. Now, if I measure it again after maybe 1 or 2 days, the same tomatoes with the same quantity, and then it came out to be 5 kgs, 10 grams. So I am the same operator. I'm using the same tomato with the same equipment. There's nothing changed. If there's any variation observed, that is called a repeatability. Okay. So repeatability is to check the equipment variation. Repeatability is the amount of variation which is observed when the same item is measured again by again using the same operator, using the same equipment. So it is same, and same. It is also known as within appraiser variation or equipment variation, because here either there is a appraiser variation, either there is an equipment variation, or there is a variation between the first trial and the second trial. So this is repeatability when the same person is measuring the same equipment, same piece with the same equipment. That is repeatability. Now, what is reproducibility? Reproducibility is done to check the operator variation. So now, instead of Simarpreet, now it is Anand, who is measuring the same tomatoes quantity, and Anand comes out as 6 kgs. So Simarpreet says 5 kgs. Anand says 6 kgs. So the amount of variation observed between Simarpreet's observation and Anand's observation is called reproducibility. Here, everything remains the same. It is only the operator which is changed. It is the same quantity, same part which is being measured. It is the same equipment which is being measured. It is only the change of a operator. This is also known as appraiser variation or between appraiser variation. Okay. In Six Sigma, when we do the MSA exercise, we go for both. We go for both sort of combination, repeatability and reproducibility. Okay. Just to ensure whether our measurement system is good to go or not. As per the standard, 90%, if the variation observed between two different operators or maybe three different operators is less than 10%, which means we are 90% calibrated, we would call it as a best measurement system method. It's called a best measurement system method. So which means if there are 10 different equipments which me and Anand are measuring, and out of 10, we are calibrated 9 times, which means we are 90% calibrated, we would consider it as a best case scenario where we would say our measurement system is good to go. However, out of 10, if we only match 8 times, 2 times we don't match, in that particular case, we would say our measurement system is not good to go. So only there is a 10% tolerance in the equipment that we talk about. Okay. Just one more information. Repeatability and reproducibility are the method of looking at the variation in the measurement. It is not the process variation we're talking about. Don't get confused with what we talked about in the variation of standard deviation. This is nothing linked with the special cause or the common cause. This is the measurement variation that we're talking about. What readings that I have done, what readings that you have done. That is the amount of variation that we're talking about. So I will take a pause to check anybody has any question.
Simarpreet, one question here. The example which you gave for the case that 25% that you guys later realized it's 25% and not 15%. So in that case example which you gave, was it reproducibility MSA that we are looking at? Because three different people came up with and they saw that that measure was different. That's why I'm asking.